Hello, I'm Kurt Vessenmeyer, a GIS specialist with Trout Unlimited's science program. Over the next few minutes, I will provide an overview of the freshwater resource assessment tools Trout Unlimited has recently developed for California BLM. These tools were developed in collaboration with BLM staff to meet several BLM needs, including the identification of key areas for meeting population objectives for species and communities and habitat objectives, including conservation of high aquatic biodiversity areas that are relatively intact, and restoration opportunities within important biodiversity areas requiring restoration. This is particularly relevant to the resource management planning process. Second, BLM recognized the need for consistent guidance and data for considering aquatic resources during project development and evaluation. To address these needs, Trout Unlimited modified its existing tools, the Conservation Success Index, and worked with partners to develop a freshwater species database, and modified Mr. FAT, or the Meadow Restoration Fish Assessment Tool, a limiting factors analysis developed for Sierra Meadows. We believe these tools can help California BLM articulate a vision for aquatic conservation, all allowing it to be competitive for internal and external. The Conservation Success Index, or CSI, uses a common conservation planning structure involving, first, the assembly of GIS data, second, summary and synthesis within watershed boundaries, in this case the Aug2014 or subwatershed, and three, interpretation of the summaries based on the best available science. Here are three example factors considered by the CSI, from among the 43 current condition and future threats factors included in the analysis: roads, urban land use, and climate. These data are summarized within subwatersheds and just within BLM lands within subwatersheds. The data are interpreted and mapped across the California BLM field offices. This GIS data summary and scoring approach is similar to tools used by other agencies and groups, including the Forest Service Watershed Condition Framework, the Northwest Forest Plan, Condition Status and Trend, and the National Fish Habitat Action Plan approach. In addition to the CSI, we worked with the Nature Conservancy to develop a database of freshwater species and habitat occurrence in California. The database considers a variety of data types for species, including range data, critical habitat information, historical observations from museum records, and current observations, allowing us to map the pattern of richness for freshwater species, those listed species, and those species that are BLM special status across the state. Both tools are available online as web maps. This example shows current habitat condition from the CSI, with high or best scores in blue and low scores in red. This map is clickable and zoomable. Scores and summary data are provided for watersheds. Here we can use the information to consider the relative condition of aquatic habitats in the watershed relative to others in the region. This watershed has low CSI scores for watershed conditions. By turning on the other layers, we can see that this is due to 3D listing for sedimentation, road densities, and high amounts of roads within floodplains on the BLM lands in the subwatershed. For looking across watersheds, the web map also supports simple filtering. In this example, users can identify watersheds with substantial BLM ownership that have dense forest stands that may warrant restoration thinning, yet lack other anthropogenic stressors. More complex queries can be performed within a GIS. Shifting from the landscape scale perspective of the CSI, The TurboFat tool provides a means for considering species limiting factors relative to project designs or proposals and the associated effects. Projects are scored to reflect the degree to which species limiting factors are affected by the proposed action. The TurboFat structure is informed by local information in addition to watershed scale information, while species-specific information can come from species recovery plans. These data are used to score a species limiting factor at a site on a 1 to 5 scale based on the importance of a list of stressors locally. Separately, the proposed effects are evaluated from a list of stressors and scored. The limiting factors and project effects are linked to arrive at project scores, which reflect the degree to which a project addresses or affects a species limiting factors. By evaluating project alternatives, this approach allows for the transparent contrasting of proposals and identifying projects' modifications that improve project outcomes. The TurboFat process has been set up as a user-friendly web-enabled tool similar to TurboTax. Results are stored in a password-protected web database. Here, an example project considers the effects of a proposal to remove 1 mile of road in a floodplain for Wall Canyon Sucker. The project location is recorded within a web map. And the limiting factors related to the species community structure and population size are evaluated based on a scoring key at the top. These factors have varying effects on Wall Canyon Sucker and are scored accordingly. After evaluating other limiting factors, project effects are considered. Here, habitat patch size for the species is increased by improving lateral and off-channel connectivity. Scores are again assigned based on the scoring key and key comments captured. TurboFat calculates limiting factors addressed relative to project scope and limiting factors addressed by the project. Project report is generated that lists limiting factors and project effects. This can be downloaded and used in project preparation, such as NEPA documents. For example, in considering 2 alternatives, TurboFat results can be charted to show relative limitation against project effect. Here, Project B addresses more of the water quality limiting factors than Project A. Taken together, the CSI freshwater database and TurboFat combine a watershed assessment and a project evaluation tool and can be used in conjunction. For 3 hypothetical projects shown here, the tools can serve as a series of filters for identifying priority projects based on landscape context and species need. Completed projects can be accounted for using the TurboFat database and fed back into subsequent watershed assessments to change the color of the condition maps, reflecting conservation success. This is just a whirlwind tour of the freshwater resource assessment tools Trout Unlimited has developed for California BLM. More information is available online or from Trout Unlimited staff.